Hello, everyone. This is Lab 3 called Black Hole. So, the purpose of the lab is to find ways to find missing variables using what's given. And this lab is structured in two parts: finding the mass of the black hole and finding the velocity of the spaceship. And we're going to be using gravitational force as well as using Newton's second law. So, here's part one. And in this part, we're going to find the mass of the black hole. And so far, we're given a few variables and we need to use what's given to find what's unknown. So now all we know is a gravitational constant with G, the mass of the star dot M, the time intervals, delta T, and for this lab, we're going to be using a day, which is represented as 86,400 seconds. We have in the top right corner the initial velocity as well as the final velocity, and we're going to compute the initial and final momentum vectors. P initial being the mass of the star times the initial velocity, and P final being the mass of the star times the final velocity. And we did that using the momentum principle, or Newton's second law. And we want to calculate the change of velocity and the change of momentum. And all that is on delta V. It's just the final velocity minus the initial velocity. And the same thing for delta P, which is the final momentum minus the initial momentum. And to find dp dt, we divide delta P and delta T. And F net is just dp dt. Now we want to calculate dp dt parallel. And P hat is just the vector divided by its magnitude. So it's the initial position, not position, the initial momentum divided by the magnitude of momentum. And to find d mag pdt, we take the magnitude of the final momentum minus the magnitude of the initial momentum and divided by the change in time. And the pdt parallel is equal to the two variables that we calculated before that multiplied by each other. And f net parallel is equal to the pdt parallel. And now we want to calculate the pdt perpendicular. And it's really simple. All we do is subtract the PDT and the PDT parallel to get the PDT perpendicular, and F net perpendicular is equal to the PDT perpendicular. And to find the mass of the black hole, I use the gravitational force formula, which is the gravitational constant times the mass of the black hole times the mass of the star divided by the position of the star squared. And doing that, I did algebra and I isolated the mass of the black hole, and that's the formula I came up with at the bottom. And what I did with those numbers is it calculated the mass after every time interval. So I added up all the masses and I divided it by the amount of time intervals. And that's what we got as a result, which is 6.03174 e to the 33rd. And part two, don't crash. We know the mass of the black hole, and there's a planet orbiting the black hole closer than the star. Now we need to calculate the velocity of the spaceship in order to not get caught in the black hole or crash into the planet. And once again, here are our knowns. From the last part, we know the mass of the black hole. And to find all the forces acting on the systems and sources that's given to us, I took the gravitational force formula, which is the gravitational force times the mass of the source and the mass of the system divided by the displacement squared, multiplied by the displacement unit vector. Oh, and it's also negative. And those are the formulas I came up with for the variables. And using all of that, I came up with a speed for the ship in order to not make any mistakes. And with those numbers, we managed to not crash into the black hole or the planet. And for the conclusion, so what if I wanted to enter orbit around the black hole? Well, I couldn't figure this out. Unfortunately, it was outside of my knowledge, but it is something to think about. and also the difference between changes of force and momentum. So the changes of momentum is that the parallel component causes a change in magnitude of momentum, and the perpendicular component causes a change in the direction of momentum. And the changes in force is that the proximity of the system to the source changes the strength of the gravitational force.